All right, good morning, everyone. Today we'll be seeing some exercise based on geochemistry, which will help you out in solving the numericals and the questions that comes from the geochemistry in the various examination. So let's begin. Here is the question: the SiO2 value recalculated on volatile free basis of the rock whose major oxides weight percentage compositions given below is what? Given answer up to 2 decimal place. So here SiO2 value is recalculated, right? On the volatile free basis of a rock. And major oxide weight percentage is given here. So you have to calculate the SiO2 value percentage, right? Originally it was 100% or 100%, so 4.28% was volatile, so that has been removed from here in the composition. So now you will have to calculate for this. So can anyone solve these questions? Look here, the SiO2 value recalculated on the volatile free basis of the rock, and the composition is given below, and you will have to calculate the SiO2 value. So the weight percentage of SiO2 is given here, and whole is this one. So if you want to calculate for SiO2, then it will be 45.58 divided by 95.72 multiplied by 100, so it comes approximately 47 point something percentage, 47.61%. All right, just have a look what answer is given here, and if you look here, it's 47.61 only. All right, so like this you'll have to solve the questions. Is it clear? Was there any problems for anyone here? These type questions are asked mainly in the GATE and IIT-JAM, right? Is it clear? Can you type in comment box so that we can move on the next question? All right. Here is another questions. The O18 by O16 of quartz sample yields a value of 0.00919. The value of O18 of the quartz sample is what? And you have to use the value of ratio as V small as this much. For this we have a formula: alpha is equal to R standard minus R sample by R standard multiplied by 1000. So let's have a look here. R standard is given as this one, 0.002005. All right, minus this value 0.0019 divided by 0.0025 2005, sorry, multiplied by 1000. So from here, if you'll see, just try to solve it out. Take the calculator. Point 0.02005 minus 0.0019. It is coming. Result is coming as 0.000105 divided by 0.002005 multiplied by 100,000. So it is coming as 52%. 52.36 parts per billion or something like that. It's a parts per billion, parts per thousand, sorry. Is it clear? So like this, you'll have to solve the questions. If it's clear, then type in comment box so that we can move on to the next question then. As we'll be explaining one more time, we'll see it once again then. So there are so many numericals which we will be solving again. One more time, right. Here it is given that the O18 by O16, it is found mainly in cold water, it is found in normal conditions, of a quartz sample yields as a value of, the value of this is this much. The value of O18 of the quartz sample is dash. That's what you have to calculate. And for that, we have a formula. If you want to calculate this value, then we have formula alpha is equal to R value in a standard, R standard minus R sample, the value which is given here, divided by R standard, and which is multiplied by 1000. So here the value of R standard we'll be taking as a V small because it is given here. We have to use this value, which is 0.002005, which has to be subtracted by the sample value, which is 0.0019 divided by R standard, which is 0.002005 multiplied by 1000. So if you subtract it, you get as 0.000105 and 0.002005 multiplied by 1000, and which comes as 52 point something if you will be going to solve 61 or something जो भी answer आया था. Is it clear now? It's a simple question. You'll have to do the calculations and if you have formula, right? So for more details, for more clearance, we'll be seeing other questions as well, which will help you out in understanding the more. All right, it's clear, right? That's good. Here we have another type of questions which we will have to solve. The ionic strength of a solutions having this much molar of NaCl and this much molar of CaCl2. This we'll be seeing later on. Before that, you just try to solve these questions and I'm waiting for your answer. Everyone please solve the question. All right, so hope you understand how to solve this question. It's quite easy. No, why to use that value? If it is given here, the standard value is there, na? All right. Ionic strength, this will be seen. Yes, there is a question, a continuous 100-meter thick sequence of a shale was deposited in 10,000 years at uniform rate of sedimentations. The number of samples that must be collected at equal stratigraphic intervals to the sample that succession every 100 year. So it was deposited in 10,000 year, right? And at uniform rate of sedimentations, the number of samples that must be collected at equal interval of 100 year. So 10,000 year, in 10,000 year it has been deposited, and you want to calculate the sample no matter what thickness you require, right? So at every 100 year, how many sample will be collected? 100 sample must be collected at equal interval of 100 years, 1 century, right? Is it clear? In the Garnett formula, Fe 2.5, Mg 0.3, CaX, AlSi3O12. X represents the number of atoms of Ca. The mole percentage of glossular in the garnet is what? This is what you will have to calculate. And if you'll see here, in the garnet, it create whole thrice. The sum should be the 3. So in case 2.5 plus 0.3 plus x is equal to 3. So x equal to 3 minus 2.8. So x equal to is coming 0.2. So now from this you'll have to calculate the molar percentage. So mole percentage, this will be in the upper side and divided by the whole, that is 3, and multiplied by the 100. So here you'll receive some answer. Let's check it out how much the answer is coming. $6.66. All right. So this will be the answer. 667%. So you have to give only one decimal place. So you'll write as 6.6. One answer you are getting, that should be there. All right. Is there any problem in this? No. All right. Now calculate for almandine. For that you might remember the formula of almandine. The formula of almandine is Fe3Al2Si3O12. So in that respect, you will have to calculate, which means the weight percentage of Fe mole you will have to take, mole percentage of Fe you will have to take. That means the 2.5 divided by 3 multiplied by 100. So whatever answer you will be getting, that will be your answer. Look, mole percentage of almandine garnet shall be 2.5 divided by the whole multiplied by 100. So you'll receive something here. Is it clear? Something 83% or something like that. All right. Next question for pyrope, and in pyrope you will have to calculate for Mg. In the same way, which will come approx 14 or something percent, 14 point something percent. So here this will be seen here now. When the duonite comprised of pure phosphorite undergoes melting, the weight percentage of MgO in the melt is dash. And molecular weight is given over here, but before that we have to know what is the formula of phosphorite, that is Fe2SiO4, and we have to break it into these moles. So this will be 2 FeO phosphorite MgO, Mg2SiO4, 2 MgO plus MgO plus SiO2, O2 plus O2. No, oxygen has been already taken. So equation is balanced. So this is having 2 moles here, and this is having 1 moles here. So for weight, for MgO percentage, what we will be doing? We have here 2 MgO. So you will be have to calculate for 2 MgO only. 2 into 40.30, which is equal to 80.60, while SiO2 is given here as it is. So for MgO percentage, mole percentage will be 80.60 divided by the sum of holes, that will be 80.60 plus 60.08, which comes here as 80.60 divided by 140 multiplied by 100. So from here, if you solve this, you'll get 57.29. 57.29%. Is it clear? Hope you understand how to solve this. Is it clear or not? If it's not clear, then I'll explain you one more time. Be quick. Clear. All right. Let's read the question first. When a duonite कौन सी रॉक होती है जिसमें 95% से ज्यादा क्या होता है, ऑलिविन होता है. ऑलिविन कोई सा भी हो सकता है. तो यहाँ पे लेकिन उन्होंने बोला कि प्योर फॉस्फोराइट है और इसकी मेल्टिंग हो रही है phosphorite is there, which means Mg2 SiO4, ये हमारा फॉर्मूला होता है phosphorite का, ये है यहाँ पे. Then the weight percentage of MgO in the melt. मेल्ट में MgO का वेट परसेंटेज क्या है वो आपको बताना है. एन आंसर इन 1 decimal place you have to give, and it is given that molecular weight is given here. ये molecular weight है और आपको वेट परसेंटेज निकालना है. तो इसके लिए हम क्या करेंगे, हमें पता होना चाहिए कि वेट जो है MgO का है, Mg2 का नहीं है. The weight here is given of MgO, not of Mg. So what we have to do, we have to break the phosphorite Mg2 SiO4 into these components only. ये जो component है, we have to break into these. So here what does it mean? MgO, that means Mg2 क्या लिख देंगे हम, 2MgO plus SiO2. Look here, how many Mg is here? 2. How many Si is here? 1. How many oxygen is here? 4. And now see the right hand side. How many Mg is here? 2. How many oxygen? Oxygen is how many? 2 is here and 2 is here. So this becomes 4 and silicon is as it is here as 1. So equation is balanced. And now we have got according to them. But actual product is these. And we have to calculate the weight percentage of MgO. So MgO का weight percentage जब हम निकालेंगे, for that what we'll have to do is that first let's calculate the molecular weight. And for this MgO is given, but we have 2 MgO, which means 2 multiplied by 4.30 plus SiO2 is given here, which is 60.08. Is it or not? इसका हम sum कर देंगे, which is 140.68. अब जिसका भी आपको निकालना है उसको आप देखोगे. उसको क्या करते हैं हम? Let's suppose there are two things, A and B, and if you want to calculate the weight percentage or either mole percentage of A, so then A for mole percentage of A, it will be A by A plus B into 100 always. For B, it will be always B by A plus B into 100. So in the similar way here, if you'll see that for which we are calculating, for MgO it is 80.60, इसको multiply कर लो, divided by whole 140.68 multiplied by 100, which is coming as 57.2 or something weight percentage. So this is our answer. Is it clear or not? Clear. All right.